Hello everyone, welcome to CloudOps Craft. Okay, today we are going to discuss about how the internet works from URL to server. Okay, so every time you type a URL like www.google.com into your browser, an entire chain reaction is set off behind the scenes, involving IP addresses, DNS servers, encrypted connections, load balancers, backend servers, and more. In this video, I'll walk you through what really happens from your browser all the way to the server. And we will break each and every step down using real world examples so that it's crystal clear even if you are just starting. Okay, so first, when you type a URL, okay, when you're typing something like www.youtube.com and hit enter, your browser first needs to find out where this website was stuck, right? So that's like saying I know the name of the restaurant, which is YouTube, but I need to find its street address to visit it. So we know the URL, right? So from URL, we will find the address, which is IP. Okay, we know the domain. Okay, using that domain, we will find the address, which is IP. Okay, so the thing is, uh, DNS is like the phone book or contact list of the internet. You give it a name like for example youtube.com, and it gives you a number like some IP address like 198 16.32.42, like that, for example. Okay, that is the number, the real address. So here how will be the flow is: browser checks its cache, OS checks a local memory, router checks its cache, ISP asks DNS hierarchy. So the DNS hierarchy will be from root to, it will go to TLD, from TLD to authoritative DNS. I will explain what is TLD, DNS, like all these things in detail. Okay. So, for example, it's like looking up a restaurant on Google Maps. The name is easy to remember, but what we really need is the coordinates of or the street address. So, first we have to understand the DNS lookup flow. Okay. First, we have to understand the DNS lookup flow. Okay, which is from root to TLD to authoritative DNS. Okay. So the thing is, when browser tries to resolve a domain like www.youtube.com, it does not know where the YouTube servers are. It needs the IP address. So it performs the DNS lookup, and this happens in three stages. Okay. First stage is, first stage is root DNS server. Okay. This is the starting point of the entire DNS hierarchy. Think of it like the receptionist at the global directory office. What it does, when you ask where is www.youtube.com, the root server says, I don't know the exact address, but .com handles uh, that. Okay. So because YouTube ending with .com, right? So it will say that this .com handles that. So it has the .com server. Okay. There are 13 main root servers globally, each identified with the letters A to M. Each will be identified from the letters A to M. Okay. So second part is, I said three stages, right? Second stage is TLD DNS server, which is top level domain server. Top level domain server. This one in short we will call as TLD. Okay. TLD stands for top level domain. Okay. Top level domain server. Okay. So in www.youtube.com. Okay. So here we take example of www.youtube.com. Here .com is the here TLD is the .com, okay, which is the TLD. Okay. So for example, if I type if I use example as www dot, okay, something like some websites, okay, for example abc dot co dot uk. Here TLD is dot uk. Okay, what it does, the .com TLD server says, oh, for youtube.com, go for the authoritative server for YouTube. Like a real world example is, think of .com, .org, .edu, okay, .in as a department in office building. Okay, .com handles all the .com queries. Okay, this is second level. Okay, second stage. Third stage is authoritative DNS server. Okay, so this is the third stage. Okay, this is the final authority on the domain owned by the company or its domain provider, like the Cloudflare, AWS, Route 53, etc. What it does, it gives you the real IP address. For example, for YouTube, www.youtube.com, right? So for this, it will provide one IP address. Okay, like 192.0.5.446, like that. It will provide some output. Okay, so now we got the address at our third stage, right? So first we know the DNS name URL. We have to find the address. At the third stage of DNS lookup flow, we found the address. Okay, so here you have to understand DNS server. Root means go to the .com department. Okay, .com TLD. Okay, .com is the TLD here. Go to YouTube DNS server. Okay, and it will provide authoritative DNS. Stage 3 will provide you the IP of the URL. So how it will works, from browser to root to .com, which is TLD. Okay, so from TLD, now it takes .com and it will go to youtube.com. Okay, so authoritative, what it will do in stage 3, it will go to IP and it will provide you the IP address. Okay, this is how it works. Okay, so next you need to understand here is TCP IP, three-way handshake. Okay, so TCP three-way handshake. Okay, now your computer knows where to go, which means it knows the IP. But before it can talk to this server, it needs to establish a connection, right? Think of it like calling someone. You can call them like, can you hear me, like that. They what they will say, yes, I can. Can you hear me? Again they will ask. Again what you say, yes. So after that, it indicates that connection ready. This is the three-way handshake, TCP three-way handshake. Okay, first you will call. Okay, you will get the response. Again you will confirm that response. That is the TCP three-way handshake. Okay, so the thing will be like, how it will be is, from client to SYN. Do you know, like, is anyone having any idea about SYN, which is synchronize? Okay, so client to synchronize, and it will ask, can I talk? Okay, server to, okay, server, what it will do? It will do synchronize, acknowledge. Okay, yes. Can you hear me, like that? Again, client, what they will respond, they will acknowledge yes. So connection will be established. So connection will be established. I will explain this in detail, okay? So you will understand in depth, okay? Before data, okay, like a web page, can travel between your browser and your server. They must establish a reliable connection using TCP protocol. Now I'll explain how it works, okay, with step by step, okay. So step one we know, okay. First step is synchronize, okay. This first step we will call this as a synchronized step, okay. Step one will be synchronize, okay. So client, which is browser, okay, it will like it will send request to server and it will ask, can I talk to you? This packet says I want to open a connection, okay. In step two is synchronize plus acknowledge, okay. So server will talk to client, okay. Here server will talk to the client, okay. The server will talk to the client, yes, I am ready, can you hear me, like that. This confirms the server is listening and asks the client to respond. Again, third step, step three will be acknowledge, okay. Again, okay, client will talk to the server, okay. Yes, I can hear you, let's talk. This is the final step, confirms that connection is two-way and open. So step one will be client to server, okay. Client is the browser, okay. So client to server, okay. Step two will be server to client, okay. Step three will be, I hope you know, client to the server, client to the server. This is how it works, okay. Then you can ask, what will be the final result? The connection is now established. Now they can exchange data safely and reliably, okay. So this is how it works, okay. So next is HTTPS and TLS encryption. But wait, before your browser starts sending data, it wants to make sure that conversation is safe and secure, right? That's where HTTPS comes in. This S means secure, okay, powered by something called TLS. TLS stands for Transport Layer Security, okay. That only we will call as a TLS encryption. For example, it's like using locked mailboxes and sending your messages in code. Only the browser and server can read what's inside. Okay, here while coming to TLS flow, first is browser checks server's SSL certificate. They agree on encryption keys. All future messages will be encrypted. So HTTPS equal to HTTP plus SSL by TLS, okay, for encrypted messages, okay, and it will verify the identity, okay. So the flow will be browser checks the SSL certificate, they agree on encryption keys, all future messages will be encrypted, okay. Now the next step is HTTP request to the server. Now that a secure connection is made, your browser sends a HTTPS request. It's like saying, "Hey YouTube, I want your home page." It's like that. Okay. While coming to key parts of the request, here HTTP will be get method. Okay. Address, who is asking what format accepted, and path will be home. Okay. So it's like a browser to HTTP request. Okay. Here we will use method is get. Okay. Path will be root, and address is send me HTML like that. Okay. So the next step is server receives and process the request. Okay. The server now prepares your response depending on the site it may. Okay. It will run backend code like Python, Node, Java. It will pull info from database, and it will build a full HTML page for you. Okay. For example, it's like placing an order at the restaurant. You ask for pizza, the kitchen prepares the ingredients, bakes it, and sends it to your table. Okay. So while coming to web server, what it will do? App code, DB query to HTML page. This is how it works. Next process is server sends back the response. Okay. The server sends back a HTTP response like a packed parcel. Inside it may include HTML for structure, CSS for design, JavaScript for interactions, and image, fonts, APIs, everything. Okay. So HTTPS response consists of HTML, CSS, JavaScript, and images. Okay. And next, what it will do is browser renders the page. Okay. Your browser now act like an architect, building the page using the materials it received. Okay. HTML is like a skeleton, CSS is the paint and layout, JavaScript is the light and motion. Okay. So rendering flow will be like HTML, CSS, JavaScript, and images. Okay. So this is how it works. Okay. So the rendering flow will be HTML, CSS, JavaScript, and images, which is final look. Okay. So next process is catching, CDNs, and load balancing. Okay. Catching, CDNs, and load balancing. Okay. To make everything fast and global, we will use CDNs to put content closer. Okay. To put content closer to the user. Okay. We will use caching. Okay. What it will do? It stores static files in memory. And load balancing. What it will do? It will share traffic across a server. Okay. So CDN is like a pizza branch in your city. Cache is like a leftovers in your fridge. Load balancer is like a manager distributing work to many chefs. Okay. So CDN is simply, if I want to say, nearby copies. Cache is like fast repeat visits. Okay. Load balancer is like a scale traffic. Okay. So let's walk through in one last time. Okay. So So first URL to DNS. From DNS you will get your IP address. Okay, so this IP address will go to TCP handshake. Okay, so after TCP handshake, TLS will be secure. Okay, for encrypted communication. After that, what it will do? After that, it will go to next step will be HTTP request. HTTP request sent. So and after HTTP request sent, we will get server process. It will go to server processes. From server process to it will go to HTTP response. Okay. From HTTP response sent to again browser will render it. Browser renders. From there we will have CDN plus cache boost. Okay, this is invisible magic behind every web page you visit. Okay, whether it's YouTube, Amazon, or your favorite blog. Okay, this is how the internet works. If you found this breakdown helpful, let me know in the comments. Subscribe to Cloud Apps Craft. We simplify DevOps, cloud, and core computing concepts every week. Thank you.